2:14 a.m.
A monitor goes red, and nothing before this series would have caught it. This is not a recap episode. This is one real system, built end-to-end, using almost everything from all 70 episodes.
I'm Mahaz, and this is Watchtower,
a monitoring and alerting system that watches unreliable sources and tells a human when it matters. No toy examples this time. Every pattern you'll see is doing an actual job. Why one real system instead of one more isolated topic? Because a design pattern taught alone looks clean. A design pattern under real failure looks nothing like the textbook.
Same for async, same for a database layer, same for a JWT check.
So the plan here is different, 5 layers, each one introduced by the failure it actually fixes.
If this kind of build is useful to see, following along helps this reach more people. Thank you.
Here's the whole system drawn once. Data layer pulls from an API and a scraped fallback concurrently. Domain layer decides what counts as an incident using 5 design patterns doing real work.
Storage and security SQLite, environment secrets, hashed credentials, signed webhooks.
Interfaces, a FastAPI service, a Flask dashboard, and a Typer CLI, all reading the same domain layer. Ops logging, tests, scheduled reports, and real alerts by email and SMS.
5 layers. Every one of them is a scene. Let's start where the data actually comes from.
First failure this system has to survive, the primary API goes down mid-poll. The API source handles pagination, refreshes an expired OAuth 2 token, and backs off on 429s.
Every response gets cached, so a retry never re-asks a question it already has the answer to.
When that source fails anyway, a factory swaps in a scraped fallback from the status page, same interface, different origin. Both sources get pulled concurrently with asyncio.gather, capped by a semaphore.
Every payload is regex validated before it's trusted enough to reach the domain layer.
The data layer's only job, get something trustworthy, from wherever it has to. Second failure, 3 different parts of the system all needed the same config, and started drifting apart. Singleton fixes that one config object read everywhere, validated once through a descriptor.
An incident fires. 3 independent listeners react. Log it, alert on it, store it. That's the observer pattern, not a metaphor, a real event bus.
Alert channels are swappable email, SMS, webhook, behind one strategy interface chosen at runtime. Retry, timing, and auth checks are stacked as decorators on the ingestion functions, closures underneath, doing the real work.
Severity routing uses match/case, enum values in one handler out, no elif chain.
5 patterns. 0 of them are here to be shown off. Each one is fixing a specific way the system already broke. Here's the bug that actually shipped during this exact build. The config snapshot function did .copy before mutating a working copy for a test run.
Looked fine, until the test run's changes showed up in the live config a few seconds later.
Same debugging process from episode 69, compare ID of the outer object, then ID of the nested settings. Outer copy, different ID, that's fine. Nested settings dict, same ID. Found it.
One import, one word changed. Copy.copy became copy.deepcopy. Bug gone.
This is why that episode existed, not as a standalone gotcha, but because it happens exactly like this. Third failure, one interface wasn't enough. Different people needed different ways in. FastAPI exposes incidents as a real REST API, pydantic models, async endpoints, docs generated for free.
A small Flask page gives a human a dashboard view, no API client needed.
A Typer CLI runs the same logic from a terminal, fetch, report, replay, clear. All 3 call the exact same domain layer underneath. Nothing is duplicated, nothing can drift.
And yes, there's a 10-second hinter status widget too, because sometimes you just want a window that's always on top.
Last failure, the system worked, but nobody could tell why it was slow, or trust that it still worked at all. Every print statement became a logging call with a rotating file handler, nothing scrolls off into nothing.
A pytest suite covers the async ingestion path too, mocking the external API so tests never depend on it being up.
cprofile is what actually caused the async rewrite, not a guess, a measured bottleneck right here. A scheduled job archives old reports with pathlib and shootil, and generates a fresh Excel and PDF report daily.
When a threshold is breached, the strategy layer fires an email, and if it's critical, an SMS through Twilio.
None of this is glamorous. It's also the entire difference between a demo and something you trust at 2 a.m.
Every real system gets a postmortem. So does this one.
What held up, the layer design meant the scraping fallback, the retries, and the alerting never touched each other's code.
What didn't? The config copy bug caught live exactly the way it happens in real projects. What I'd change with more time, a proper Postgres swap-in, and a queue between ingestion and alerting.
Your version doesn't need to be this. Pick 3 tools from this series and combine them into something real. That's the actual exercise. That's Watchtower, one real system, almost the entire series working together.
This closes the Python arc of this channel. What comes next moves into the agentic AI era, where a lot of what you just watched becomes the foundation for it. Thanks for building all 70 of these with me. I'll see you in the next one.